Hello, my name is Christina Dervaj. I'm a senior software engineer at Grafana Labs, and I'm here to talk about how Grafana helped me get healthier. So I started at Grafana in February, and I'm really excited to talk about this project, which I got to work on during an internal hackathon at Grafana. That said, one thing about me you should know is I am not naturally inclined to be a fitness person. I try not to run as just as a personal rule. And while I have a workout program I like, I have a lot more beer that I like. I was really trying to find new ways to get me to get motivated and stay motivated. And so one thing I kind of realized as I started on this is that my goals weren't necessarily exactly what a lot of people have when they get into fitness. I want to lose fat, but I also want to gain muscle. And if my weight doesn't change much during this, that's perfectly fine by me. So looking into this, I wanted to trade up my scale for a body composition scale that would let me see more of what my weight was consisted of. So I found the Xiaomi body composition scale on Amazon for about $20 or 19 euros. And yeah, this can detect some basic body composition data like fat percentage, muscle percentage, and bone percentage. How body composition scales like this work is you step on the small little pads with your bare feet. It sends a small electrical current up one leg across your pelvis, and scale sensors on the other side detect the electrical resistance it met through your body. So then the scale ends up sending weight and impedance measurements, and an external thing needs to take in some profile data like your height and your age, and it can calculate some estimates on those percentages. So as I started using this app, started using the scale, I started using the app that the scale came with, and I also found that kind of lacking. The only metric they have over time is this thing called the body score, which was some sort of combination of a lot of calculations. And the entire app was pretty obviously focused on weight loss. They gave me an ideal weight that I really wasn't trying to hit. And there was just a lot of advice and focus on weight loss. So I started thinking about this as I got it onboarded with Grafana and got more into observability, that this might actually be kind of a common problem. For a lot of people, server latency is just a number that is enough to tell them what they need to do to fix things. They can dive in from there. But if you've got a more complex system, perhaps just how slow your server's being isn't enough. You need to see what components are leading to that slowness and be able to fix those individually. And so in the end, I ended up seeing this app as just kind of a really bad observability tool. It didn't let me configure it at all. I wasn't able to do anything with it. And I was just sort of stuck with it. And I really wasn't happy with that. So I started looking for ways to get data out of the app, off the scale, out of the app and into Grafana. And I found Lolux44's repo of the Xiaomi Mi scale. And it had basically all of the building blocks I needed to get this to work. It had logic for how to detect the correct Bluetooth signal from the scale. It had logic on how to decode that signal to get the weight and impedance measurement out of it. And then it had all of the calculations to get the measurements from that weight and impedance value. So how this system worked is the scale got data into a Raspberry Pi, which I'll talk about later. And from there, the Raspberry Pi would run all of the calculations and then send that metric data to a home automation system that this person was running. And so this was all written in Python. And like I said, it had all the building blocks, but it really wasn't how I wanted to do things. So Raspberry Pis, if you're not familiar, are basically little computers all on a board. They have an operating system. You can plug in monitors, keyboards, mice, peripherals. There's an SD card for storage, and it's the entirety of a computer just on a small scale. By contrast, microcontrollers are a computer too, but they're a lot more simple. There's a function for setting up some things. And besides that, there's a loop function that it will just try to run that code as fast as possible. So you can still get computing done, but it's just a lot more simple and a lot more bare bones. So when I was looking for something to take care of my scale problem, all it needed to do is be able to receive data from the scale and send it out on Wi-Fi. And so I looked at the ESP-32 as a popular microcontroller that uses Wi-Fi. There are tons of ESP-32 variants out there, and I found this one that specifically just had Bluetooth Low Energy, which I'll talk about in a second here. So this microcontroller costs $10 or 9.5 euros, and I found it on Adafruit. So the scale uses Bluetooth Low Energy to work. You're probably most familiar with Bluetooth as in like you go into the Bluetooth menu on your phone, you connect up to a speaker or something, and then that connection sticks. Like you keep piping data to that Bluetooth speaker and it keeps playing music, or you hook up your trackpad or something else, and then that connection is permanent. For Bluetooth Low Energy, it needs to be something a little different, where to make it good for low energy devices, the device needs to be able to go to sleep and only wake up when needed. So those devices don't necessarily have a sustained connection. When they wake up, they just sort of broadcast out Bluetooth data and on repeat generally. And the scanning device needs to know how to isolate that signal by device, generally by some sort of address, and then take that data and do whatever with it. So for me, the ESP32 was going to do that. It was just going to monitor for BLE devices when it found one with the address of the scale, and it would do some parsing to get all the data out of it. And then we could kind of just go from there. So the scale, when you decode everything, you end up getting your weight and impedance measurements. You also get the unit, whether it's pounds or kilos. And then you get a couple of Booleans for is stabilized. That is, has your weight been stabilized, your weight measurement been stabilized, or the has impedance, because that's not an instant process. There's like a little bit of time involved for it. So once you have that calculated, it will also be true. A big difference between using a microcontroller and the Raspberry Pi for this was the Raspberry Pi kind of took care of everything in one step. It got in the measurements, it ran the calculations and sent that to the home automation framework. For me, I wanted to keep the data on the microcontroller as simple as possible. So all I do is decode the data or the signal from the scale and then send the data up to the endpoint to do the calculations. So let's do the demo of the serial here. I'm going to get this plugged in. Here's my microcontroller. It's happily going. So you can see here, like this is it just looking for new devices. The number fluctuates a little bit just as devices wake up and go back to sleep or come in and out of range. So I've got my scale here and my bare feet. I'm going to step on it and you will see numbers start to appear. So there's the payload and the Booleans and the weight. It doesn't have an impedance measurement yet. There are little lights that'll go on when it starts doing. So it's finalized the weight. It's doing the impedance thing now. So once it has it, it connects up to Wi-Fi. That JSON is the Boolean or the JSON payload it sends. And it looks like this didn't work, which is too bad, but there we go. It worked the second time around. Got a 200 there. So yeah, it was able to send it out to the endpoint that picked it up. So I wanted to cover this a little bit too, because I thought this was really, really fun. Maybe this is like old hat for hardware engineers, but for me, I just thought this was kind of a fun mystery. This was all like, I didn't figure this out from scratch. It was done in Python. I just had to figure it out in what works on the microcontroller. But so the two Booleans come from the raw payload that comes off the scale. So that's not covered here. But the rest of the payload you convert into being hexadecimal. And from there, you can kind of take substrings of it to get the measurements that you need. So the unit is really simple. It's that part in the beginning there. If it's 03, it's pounds. If it's 02, it's kilograms. There's a section for the impedance value there. And what you do is you get the hex values out. So it's 4 characters, but it's 2 hex numbers. And then you swap the 2 hex numbers. So instead of C401, it's 01C4. And 01C4 is 452 in decimal, and that's my impedance value. Right after that is the hex for the weight. So that one for us was 6A40. We're going to swap that and combine it again. So it's 406A. 406A in hex is 16,490 in decimal, which you multiply by 0.01 to get 164.9, which is my weight. And then the ESP32 just sort of concatenates it all into a JSON string, which it can send on its merry way. So the backend that picks this up looks kind of like this. There's a lot of moving pieces for this AWS backend, but it's actually a little bit simpler. The first version I wrote of this was your traditional node backend that just has a server running all the time. But I found that keeping that server running for just waiting for an endpoint to get hit didn't really make a lot of sense. And something like a Lambda that only runs when you call it made a lot more sense for this use case. So what I've got here is the ESP32 gets the weight and impedance values, and it sends it up. And there's a few things it hits. For one, there's an authorization key that is hard-coded into the ESP32, and it's also hard-coded into an authorizer lambda that sits behind everything. And all it does is compare that key and make sure that it's the same. There's an API gateway to sort of route everything from an endpoint to the right Lambda. And that is all sitting behind a CloudFront distribution. This is because one thing I couldn't get working right was the ESP-32 being able to send HTTPS requests. I tried all the demos, I tried a whole bunch of stuff, and I just couldn't get it to work. So I decided to kick that can down the road a little bit and just set up a CloudFront distribution that would accept insecure traffic. I know this is not a security best practice, but I figure if I've got somebody sniffing traffic from a microcontroller that lives in my bathroom, I've probably got some bigger problems. But anyway, if everything is good, if it's authorized and everything works, it'll hit the actual measurement lambda. And that works like this. So it gets the weight and impedance value in, it pulls the user profile that's stored in RDS in the My Postgres database, and then it runs all the calculations. So then that's where you get your muscle, bone, fat, protein, and water percentages. And from then, once it's got all of that calculated out, it sends it back and stores it in RDS and will send a 200 response if everything is good. So let's talk a little bit about how we get this into Grafana. So in Grafana, you're going to go to data source here. And so this is an RDS, but it's just a Postgres database like anything else. So we're going to add this. The only thing that you need to kind of watch out for when you set this up is you need to have your RDS database be able to be accessible to outside traffic. So we'll do that. And it's that. Turn this off. And then we'll test this. Looks like we're good to go. So let's go into Explorer and see how this works. So the I'm going to actually decrease this for a second here just because it's easier to see. So the Postgres data source for Explorer works really slick here. You can pull the table that you want. You have to select what time to look for. And then we can select a columns. Let's look at muscle here. Oops. Try that. So it looks like that's not showing up, but we can actually go back over the last 90 days. You can see there's a whole bunch of hits here as I've been working on this project. This has a lot of, very steep drops, but our scale here is only like 10. So it's just not really, it's going to look a lot more dramatic than it actually is. So I'm going to do the cooking show thing where you pull the finished turkey out of the oven and get the rest of this here so we can look at everything. And this is what it kind of looks like overall. So this green bar at the top here is the overall weight. That's the total weight. Overlapping here, so it's kind of hard to see, is your water percentage, which is the red, and then that light blue, which is the muscle mass. You've got your fat mass, which is this yellow line. And then the darker blue line here is your protein percentage. And then finally at the bottom is your bone mass, which is the smallest amount. So I saw this and I was really excited. This had, again, all of the data that I needed. It didn't have any judgments. I could kind of parse it the way that I wanted to and look into things the way I wanted to, but I still found it a little lacking. Mostly fat, muscle, and bone mass, they shouldn't be overlapping. They're kind of exclusive to each other. So it was more like I wanted that to be a stacked area chart showing how the composition changed as a whole over time. Water and protein percentage are a little different, water and protein being in a little bit of everything. And so that is kind of a different measurement that should sit outside of it and sit maybe on top. So I decided to look into the wonderful world of designing your own dashboard panels. And we'll look at what that looks like. So, and we can use our brand new to Grafana 9, add the dashboard button here. We'll select a new dashboard and we'll open it in a new tab. So here's our calculations. Edit this. Let's set this to 90. So this looks pretty much exactly like what we had in Explorer, just maybe just condensed a little bit. And we'll go to the panel that I made. And then let's select pounds for this. Let's see. So one thing I didn't quite working is the legend doesn't resize correctly, which is kind of unfortunate, but it's on the to-do list. Yeah, so this is kind of what you end up with. You have your fat mass as a percentage of the whole underneath here on the bottom. Your muscle mass is on top of that. And then finally at the top, that little white part is your bone mass, just kind of sitting there at the top at all times. And then, like I said, since protein and water are percentages of are kind of involved with a little bit of everything, they just sort of float on top and just are kind of another static or another measurement on top of everything else. You might notice that there's an etc mass here that was going to be, I was wondering how much after you took your weight and then subtracted bone, muscle, and fat from it, what you'd have left over. Turns out not a lot. I left it there anyway, just in case something ever happens to someone, but really you shouldn't see a lot of that green etc mass. But yeah, this is everything I wanted, and I'm looking forward to using this more. There's no sort of judgments. I can decide what I want out of this looking at it, and then I can kind of decide, what I want to work on and stuff like that by looking at this and monitoring it. So let's talk for a second about how I built the dashboard panel. So Grafana has a CLI that has a very handy tool for building dashboard plugins, which is what I did. And I decided to use d3.js to build this. Had to dust off some old skills here. First off, I used d3.area to create the fill for the stacked area chart here. That's in the background. It's slightly translucent, so you can kind of still see the axis lines on there. There's also the axis on the bottom and the left, which gives me my time series and then the amount of weight on the side. Besides that, I use d3.line to generate the paths that go either the water and protein line that sort of are different from everything and float on top. I decided to add a opaque line to the top of each of the area charts to really kind of monitor how that is going up and down. It just seemed like a lot better than that kind of semi-transparent thing. And the legend is sort of tacked on the bottom with no real elegance. That's kind of why it has problems resizing. So yeah, this is exactly what I want. And I'm really, really happy with it and really happy that I have this tool. So let's talk about other ways that people have made Grafana work for them in similar ways. For one, on the r/Fitbit forum, a user took data out of the Fitbit cloud and was able to get it into a database that he had control over and hooked up Grafana to it, and then built an extremely comprehensive dashboard that measures everything that Fitbit tracks. So his heart rate, his sleep patterns, his steps, his exercises, other activities, they're just all in one big dashboard. This is extremely cool. I love the idea of being able to change your windows around so you can kind of decide whether you want to look at things on like more of a long-term scale, or maybe over the last 2 weeks or something like that. It just gives you a level of granularity that you would normally have to wait for an app developer to kind of plug into their system. With something like this, you can just do whatever you want with it, and it's really exciting. I don't have a Fitbit, but it's kind of making me want one. A coworker of mine, Dave Henderson, took his sit-stand desk and was able to get data on when he's sitting, when he's standing, how high the desk is over time, and get that into Grafana. And he built this really fun dashboard that has the sit-stand ratio, so a percentage there. You can kind of see that ratio change over time. And it also shows the desk height that he's got. So you can kind of see the pattern that you're using. If you've got some sort of goal for you want to stand for half the day, you can make sure that you are getting there with data. And it's just it's a really easy way. Once you kind of have to put in the elbow grease to get this data somewhere, once you do it, you have this observability tool that just sort of works and can work in the way that you want to. That's the important part. So I have some final notes here. For one, obviously, as you saw, I definitely could benefit from using the system more. I needed to kind of cash out a couple things, but now that everything is more or less working, I'm looking forward to using it more. Number two, I am not a doctor, and I would love for an expert to review these calculations. So I literally copied them off of some guy on the internet, and they do match up with what the app was saying, like the app that came with the scale. But I'm also not quite positive on how involved the medical community was for that either. So someone to kind of verify what we're doing is more or less correct, or if they're just kind of spitballing things, would be extremely useful. That said, the scale is a $20 body composition scales. And if you know anything about body composition scales, that price can go up pretty quick. So in terms of accuracy, I think it's probably better than nothing, but I would definitely, if you're really, really involved with wanting to make sure that number is accurate, you might have to go and find another method. So secondly, and most importantly, the user profile data you take to get the metrics calculations relies on a biological or a binary definition of biological sex that's not inclusive to everybody. I would really love to have a guidance from somebody on how we can provide options so anybody can select an option that's both comfortable and accurate to them. But if you're comfortable with these limitations, all of the sources on GitHub, I've got my, like all of the microcontroller code, the node endpoint, the original node endpoint, the Lambda, the schema for the database, everything is in Galicia/ESP-32 scale. The custom Grafana panel is in Galicia/body composition panel. And you can reach out to me on Twitter. I'm also on GitHub, and I'm also on the Grafana community Slack at kDerivage. So I mentioned in the beginning that this project was done as part of an internal hackathon at Grafana. Next up is a presentation from a bunch of my extremely talented coworkers on other projects that they did during that hackathon. I'm really, really excited to watch it. I got to see some of the presentations when the hackathon was done, and it's just like, it's a really, really fun initiative for the company to give engineers who find new ways to be creative. So with that, I will leave you to Q&A. Thank you so much for listening.